All right. So this is the ungraded Wiley +7. Okay, so it's number 2. So the question they ask is starting with an appropriate alkyl halide and base, outline the synthesis that would yield the following alkenes. The following alkene. Alright, and the following alkene as the major or only product. Alright, so here's the alkene that they give us. And because it's an alkene, we're starting with an alkane. We know that we want elimination. E2 or E1, who knows yet. And they give us a couple of, they give us 4 bases and solvents to choose from. So there's sodium hydroxide in water. There is potassium tert butoxide in tert butyl alcohol. There's potassium amide in ammonia. And then there's lithium hydride in ammonia. So one thing we should know, or a few things we should know about all of these bases and solvents, is that they're all strong bases, and they're all protic solvents. The only one that's a little bit different than the rest is the potassium tert butoxide, because this base, it is the only bulky base, right? It looks something like this. All right, so with that in mind, we're going to go to, seems to me that we have 3 options of the alkyl halide that we began with, right? So here's option 1, CH3, CH3, CH3. These would be H's here, right? And then we could put the bromine right here. That would be the 1. So the reason that doesn't work, in my opinion, is because if we're using any strong base, whether it's unhindered or hindered, we're not going to get the product we want. So let's say that we start with unhindered. The unhindered can either come and take a proton from here, which is going to make a double bond right here, right? We want the double bond to be here. We don't want it to be here. Or it can come and it'll take a proton from here and make the double bond right here, which we don't want either. And the hindered base, the potassium terbutoxide, would just come over here and take the proton from there and create a double bond there. So we don't get anything that we want from that option. So option 2, right, we have our molecule. And this time I made it a secondary halide, and I put it right there on the secondary. The bromine is on the secondary carbon. So again, we're dealing with strong bases. So A, if it was unhindered, A is unhindered, the unhindered bases. Now, it could go 2 ways, right? It could go over here and it could take this H right here, and then that H would form the double bond right here, and we don't want it there. But it could also, it seems to me, come here and take this H, and then that H would form the double bond right there, and we would get the product we want. However, I believe that this would be favored. And I think this route on top is more likely route because it's taking the hydrogen from the more substituted carbon. It's kind of a guess. It's an educated guess, right? Now, when I first looked at this, now let's say we have the hindered, okay? The hindered base would come, and it's not going to take the hydrogen from here. It can't because it's too crowded. So the only place it's going to take the hydrogen from is this first degree carbon that has no hindrance. And then it would take this hydrogen, and this hydrogen would give the double bond here, and we would get our product, right? So I was like, this could be possible. And I don't know, maybe if I had written it that way in Wiley, maybe there's more than one answer. But at the end of this, I'll give a theoretical reason why maybe it could not be the answer. Maybe it is. Wiley's strange, right? I'm just going to show the way that I got the right answer and how I got it. So then the third answer is I have I make a first degree halide, and I put it on the first carbon there. Now, if the strong base is unhindered, right? Strong base. A strong base with a primary halide like that is going to make an SN2 reaction. It's just going to come in here and it's going to attack and it's going to push off the bromine. And then we'll have the base connected to this. We're not going to get a double bond. So we know that wouldn't work. A hindered base like the potassium terbutoxide. Now I guess a hindered base can come in and pluck off a hydrogen from a second degree carbon. I guess there's enough space there, and then it would give the double bond right there, and then putting that double bond right there would push this off, and then we would get what we wanted. So this is the answer. The answer that Wiley gave was first degree, and that first degree halide, and then using the bulky base. So the reason why maybe option 2. I don't know if maybe someone put in option 2 and it also worked that way. And I'm thinking because now the answer said most, the major, or only. So this was the only thing I could think of why that might not work. Again, maybe it did work. Maybe Wiley would accept multiple answers. So let's say that we use the potassium terbutoxide, and I'm referring back to option 2 when I said that using the potassium terbutoxide on the secondary halide could work because it would just take this hydrogen, then this would make a double bond, and this would break off. So why option 2 is not an option? And I think it might be because there's a competing SN1 reaction, right? This is just like speculation. So I have CH3, OH. Now, it's because the potassium terbutoxide could protonate itself, right? And that would give me the potassium, the potassium butanol could self-protonate. So then I would get this. And then because there's potassium terbutoxide in with the butanol, terbutanol, that could come in and cause an SN2 reaction, taking one of those hydrogens. That would come here. This would break off, the OH2+, and then we would get water. So then we would have water in our reaction, right? And then the water, it is possible because this, of this protic solvent, let's say that we had our secondary halide and we got the beginnings of an SN1 reaction, and the bromine broke off into the solution. It's less likely because it would create a second-degree carbocation, right? It's not very likely. Usually it's going to be a third-degree carbocation, but I guess it could happen. And then what would happen with the secondary carbocation, the water would come in and hook itself in as an SN1 reaction. So we would get the molecule with the positive H2 on it. And then this could be deprotonated maybe by potassium butoxide. This seems very unlikely actually now that I'm doing it. And then we would get something like this. That's the only theory I have that maybe it wouldn't work, but then again, if somebody put that into Wiley and it worked, let me know. Alright, thanks.